Now let's discuss NVM API config class 2. So in this configuration class, it supports actually an intermediate set of APIs. So the first configuration class gives us a basic set of APIs. Now on top of those basic APIs, now we are getting some extra APIs, and then it's an intermediate set. That means we still have some APIs missing, but we have something more than the basic ones. So the new APIs that are added are highlighted in yellow here. So you can see in type 1, 2 APIs got added. In type 2, we have 3 APIs. So let's discuss each of them. The first one is NVM set data index, and the parameters that are used is block ID and data index. This API is used with dataset block management type. And how it is used? It is used for actually setting the data index of a dataset NVRAM block. So if we need to access a dataset, the first thing we need to do is set the dataset index. And this API will help us to do exactly that, to set the dataset index. And this helps us to access a certain dataset of NVRAM block. Okay, so we will be able to access the dataset. It's a synchronous API and it's of type 1. So the content of corresponding RAM block is not modified in this case. So just to be clear that we are just setting the dataset index. We are not modifying anything in the content when we are using this API. The next API is NVM get data index. And here the parameters are block ID as well as the data index pointer. So again, since it's a data index, we are dealing with the dataset block management type. And this service is used for getting the currently set data index of a dataset NVRAM block. So for a particular dataset NVRAM block, we will be getting its data index, and which is set by the previous API we discussed. This is a synchronous API and it is of type 1. Now here you can see, right, the data index pointer is used to store the current dataset index. Okay. And before using this API, we should initialize the NVM module. So that's about this get data index API. Next we have the NVM read block. And this is also important, like in the previous config class, the most important ones were the NVM read all and NVM write all. So when we go to the block level, instead of multi-block, there comes the NVM read block as well as the NVM write block. So let's look at each of them. The first one is here is the NVM read block. Okay, so it is a service used to copy the data of NV block to its corresponding RAM block. So anything that is in NV block, we can read it to its corresponding RAM block. Simple. It's just a reading of one block. It's an asynchronous API and it's of type 2. Yes, you can see here the second parameter, NVM destination pointer, is the pointer to the permanent RAM data block. So if we have a permanent RAM block, then this block's pointer is given by this argument. Now suppose if the RAM block is temporary, then we will not have a corresponding pointer, right? So in that case, we can pass null pointer. Now whenever we request for this, the read request is queued in a job queue. So multiple read requests will be there. All of this will be queued and one will be handled one after the other. Now in case of NV RAM block management type dataset, the job of the function NVM read block shall copy only the NV block to the corresponding RAM block, which is selected by the data index. As you know, in the case of dataset, we have multiple blocks arranged in a sequential fashion. So if we try to do this NVM read block operation on a dataset, it will read that block which is corresponding to the currently set dataset index. Okay, so only that block will be read. Now again, if the job of the function NVM read block, it will request a CRC recalculation over the RAM block data after the copy process. Suppose if the NV block is configured for the CRC. So we'll perform a CRC recalculation once this data is copied, just in case the CRC mechanism is configured for this particular block. Now let's look at the NVM write block API. Again, the parameters are similar: block ID, NVM source pointer. It is a service used to copy the data of RAM block to its corresponding NV block. Okay, so from the RAM block, now we are copying the data to its corresponding NV block. It's an asynchronous API and it's of type 2. Here also, as you can see, right, the second argument or the second parameter is the NVM source pointer, and it is a pointer to the permanent RAM block. So if, for example, the RAM block is temporary, then we can pass a null pointer. Now, another thing we need to be careful whenever we use write APIs is that write protection attribute. Okay, that should be checked whenever we perform this NVM write block. Now, the function NVM write block shall cancel a pending job immediately in a destructive way if the pass block ID references an NVRAM block configured to have immediate priority. So what happens is, for example, as I told you, when multiple times when there are read requests or write requests, the queuing happens. But suppose something happens, that is some write operation, write block is called for an immediate priority, then we'll destructively cancel the immediate job or the pending jobs and then initiate the write block for that particular block ID. Okay, so that's one thing we need to be clear, that whenever immediate write block happens, then that will take priority over the pending write requests. Now the job of the function NVM write block shall request a CRC recalculation. So again, if the CRC is configured, there will be a recalculation whenever the data is copied to NV memory. The next next API we are going to discuss is the NVM restore block defaults. The parameters are block ID, NVM destination pointer. This service or API is used to restore the default data to its corresponding RAM block. So in case some error happens, we get the default data, and this is copied to the corresponding RAM block. It's asynchronous API and it's of type 2 category. The request here is queued, just like the previous one. Whenever the request is there, it will be queued. And the default data can be loaded from ROM block if ROM block is configured. Okay, so if it is configured, we can directly fetch the default data from ROM block. Now, if no ROM block is available, then an application callback, NVM init block callback, is used. So we can provide either of this. First is give a ROM block, or second option is give a callback in which we provide the default values. So that's all about the NVM configuration class 2. In the next session, we will discuss NVM configuration class 3.